Hello everyone, welcome to the next class on the probability and statistics. Today we will discuss about the exponential distribution and we will also see how to calculate the probability by using the PDF and the CDF function. So myself Dr. Garg, working in the School of Mathematics, Thapar Institute, India. You can send me any email IDs, so you can send me any emails regarding your queries related to the probability and statistics, or you can follow this link for more the updates. So in this lecture, we will study the exponential distributions are there, and you have already watched the last lectures related to the Bernoulli, binomial, Poisson, geometric, negative, and the uniform distributions. If you miss any one of them, you can simply browse this channel, Dr. Harish Garg, or you can simply click on this link to find all these previous videos are there. So what is the exponential distribution and why we use these exponential distributions are there? So firstly, exponential distribution is basically used for the time related things are there. As we have seen in the Poisson distribution, these are working for the time related problems are there. The same thing in the continuous distribution, exponential distribution. In case of the continuous random variable, exponential distribution is working for the time related problems with average as a constant rate. So what is the exponential distribution is this. So where this lambda is called as the rate parameter, and in generally it represented as x follows exponential with the parameter this. Now the question arises is why this e is negative is there, because we also know that this is also the exponential function. Why only this negative part follows this exponential distribution? So in order to explain this, look at that there are the two kinds of the exponential function, with having the positive sign, having the negative sign. So if you draw the graph of this, so what is the graphical representation of this? Look at that. So this value is my 1 for any x is 0, and the s is an increasing function. On the other hand, for this one, the graph is like this way. So if I call as this is my probability density function. So first of all, when you say that it's a probability density function, so if by the definition is, if you call this as my 1, okay, so if I call as this is my x, so this is infinity and this is minus infinity. So look at that, this is the below side. So if you can you say that this area is 1? No, because the area of here is 1, and after that if I say this, the value of here is say 4, this value say 9, and up to the infinity. So this will never be equal to 1 in case of any of the case. So it means the exponential distribution of positive sign will never follows the probability distribution function. So it means this case will be ruled out. On the other hand, if this is the case, then it can be the 1, provided if this value is not be a 1. If I say this value is say my half, or say 3/4, or say 0.7, and you have to find this because this is the converging sequence. So you can find that this is my 1. So how you find that? So if I just consider the function here, instead of taking here as a this, I can also consider this as this is as a 1/2, this is 9, and so on. So in general I consider this as a is my unknown. Okay, and my task is to form this a. So if you draw the graph of this, what is the graph of this? Look at that. This is my a. Now, when you can say this is my PDF, so how you find this value a? So in order to find the PDF, we know that the integration is 1. So once we substitute here, and this value is 0 to infinity, so you have to replace this as here. So after integrating, you will get this as a is nothing but my a. So look at that. So it means my f of x will be here. Look at that. If this is a, then this is also b. The same a is here. So based on this logic, we define the exponential functions as this, where the parameter is called as the unknown parameter is called as the rate parameter of the exponential distribution, and this is defined like this way, where capital X is called as the exponential distribution. So look at that, how many unknown parameters are there in this exponential distribution? Only one, that is a lambda. Now if you calculate the mean and the variance of this exponential distribution, you will find this. And I think all of you know that how to calculate the mean is by using this rule. And if you substitute the value of the fx from here, So limit start from the 0 to infinity. So you can start from here, this. Okay, so after solving this, you will get this value as there. And if you carefully look at that, I just give you hint, you can try to prove yourself. This is nothing but the gamma distribution is there, or you can say the gamma function. You can use the gamma function, or else you can integrate by parts. And how you find the variance is ex square minus of ex whole square. So once you solve this, you will get this. So can you find the relation between them? You can see that the variance is nothing but the mean square. Okay, so if I say mean is my 9, so the variance is automatically be 81. Now how you find the CDF of this exponential distribution? So this is my PDF of the exponential distribution, and you know that the CDF definition is f of x is nothing but here. So what is the domain is? Your domain is my 0 to here. So how you find that? So your target is to find this. So if you look at this, how many parts are there? This is the first part. This is second. So you can write the first part as x less than 0. Second part as x greater than 0. So my task is to find these two things with the help of here. So I will consider one by one. So let's start with the case 1 when x lies here. So how you write this? So what is the value of the fx when x is less than 0? So value of the fx when x less than 0 is 0. So you will get this answer as 0. Case second when x is lies here. So how you then how you write here? So you can start from 0 to minus infinity to 0 and 0 to x. Okay. So what is the value of this is fx, and here is my 0. So how you find that? This is my 0. So this is constant outside. This is there. So once you integrate this, so what will happen is you will get this integration, and after solving you will get this. So it means this value is here. So finally you will get the CDF of the exponential distribution as here. So you just remember the CDF of the exponential distribution as this, and it will be very beneficial when we will solve the probability solver. So let's discuss with some 8 examples we will discuss in this video. So look at the first example is there. Let x be a random variable with the probability density function. So this is my PDF, and this is there. So firstly you have to find the value of a. So there are the several methods you can find the value of the a. So I just discussed the 2 methods. First method, if you look at very carefully this function, and this is given to be a PDF. Okay, so what is the meaning of that? So if it is a PDF, and you can think about that which function is there. So look at that. If you compare this function with this, can you find the value of lambda here? This is there. So what will happen? So a is nothing but 1 by 3. So if you compare this, look at that, whatever the coefficient of the x, that is same as that of this. So what is the coefficient of x is 1 by 3, and a is my 1 by 3. So this is the first method. Otherwise you can also use the second method by the definition. So this is fx is given for the PDF, because it is given to you. This is the PDF. So for PDF you have the integration 1. So once you will substitute this value is greater than 0, so you can break this as here. So this value is my 0. This value is my a of x by 3 of dx. So now you can integrate them. So this is, look at that, this part is 0. So the only part is 0 to infinity of this. So now a take outside, and you can take the integration. This is 1, and after solving this you will get a as 1 by 3. Second part is we have to find this value. So again we will solve this with the help of by using the PDF and by using the CDF. So we will discuss again the 2 methods for each problem. So firstly we will discuss by the PDF. So what is that function? PDF means this is there. So you have to take the integrate from 3 greater than 3. So the domain is 3 to infinity of fx. Now a is my 1 by 3. So you can simply integrate it. You 1 by 3 is outside. So now this will be cancelled out. So it will be negative. What will the infinity value is 0, and 3 value is 1. So the answer is 1 by 3. On the other hand, if you want to calculate by using the CDF, how you write this in terms of the CDF is, so look at that. What is the definition of the CDF is this. So it means what you need is you have to firstly find the function which is less than sign. So this is greater than. So you firstly convert into the less than this. Now what is that? This is my 1 minus f of 3. You can write is as f of 3. Now this is the exponential distribution. What is the CDF? This is the value. So you can substitute the value as here. What is the lambda we have calculated is 1 by 3. Lambda is nothing but my a in this particular question. So if you substitute a is my 1 by 3 and 1 will be cancelled. So this is here. So the answer is -1. Look at that, the same is there. Okay, so this is the second method. You can follow any one of them, but I always prefer this because there is no need to integrate the function, but here there is a need of the integration. Look at this function. You have to find the probability that x lies between 1 and 4. Again we will see the two methods by using the PDF and by using the CDF. So if it is 1 to 4, you can write like this way. 1 by 3 is outside. You can take the integration. Okay, so this will cancel out. So it's a negative. Is e raised power -4 by 3 and so on. So it will here. On the other hand, if you write in terms of the CDF, how you write that? If you remember that in our last videos, in our videos related to the CDF, how you write that this is FB minus f of a. So f of 4 minus f of 1. So what is the f of 4 is? 1 minus e raised power -4a. And what is the f of 1 is? -1a. So you can substitute the value of a here. A is my 1 by 3. So you will get the same answer. So remember, this is a 3-step rule. Look at the second example. The time in hours is given that is exponential distribution with parameter. So what is the exponential distribution parameter is lambda. What is the probability that repair time exceeds 3 hours? So that's your target. You have to find this one. So lambda is given to this. So it's exponential distribution here. So what is the required probability is x greater than 3. So again we will use by PDF or by CDF. If you use it by PDF, this is by using PDF, then is 3 to infinity this. So after calculation, this will be my -1. If you substitute infinity, is a 0 and this is -1. So you will get the answer as 1 by 3. On the other hand, if you calculate this by using the CDF, then you have to write in terms of CDF. This is a greater than, so you have to write in less than 1 minus. This is 1 minus f of 3 and this is the same answer. Now look at the one more important property that is called as the memoryless. It only happen in the exponential distribution. While in case of the discrete, you may remember that we have discussed that in geometric distribution, okay, this memoryless properties follows that. While in the continuous distribution, exponential distribution and the gamma distribution follows that. But now what is the memoryless property for the exponential? It always works for the conditional probability. X greater than m, conditional x greater than n is nothing but probability of x greater than m minus n. So we will explain it with the help of the example. So look at this example. The fast food chain find the average time has to be follow 75 hours. So this is the average. There is a mean. It's a 45 seconds. If the waiting time is the exponential distribution, so this is the mean of exponential distribution. What is the probability that a customer will have to wait more than 5 minutes? Given that it's a condition, already he is waited for the 2 minutes. Okay, so you have to find this one. So what is given that is a mean is exponential distribution is 1 by lambda. So this is there. Now what is your required task is this. Look at that, this is a second, this is a minute. So you firstly convert this into the minute second. So 5 minutes is nothing but my 130 seconds. And this is 120. Now how you find this probability? So there are the several ways. Firstly, you know that how you just know that what is the meaning of the A condition B. A intersection B divided by PB. So if you find this probability of this conditional, so the first method is look at like this way. What is that? x greater than 300. So if I say this is greater than 300, this is 120. So what is the common intersection is this portion. So x here is this. Now how you solve them? This is exponential distribution. So it's this here of dx divided by say greater than 120 here. So you can solve this integration and substitute the values, you will get the required result. Otherwise you can use them by the CDF. You can express this as 1 minus. So this is nothing but f of 300. This is f of 120. Now you can substitute directly as a CDF. What is the CDF is? Here. Okay. So lambda is, I just calculated as 1 by 45. X is my 300. So you will get this answer. This is the first method. So look at that. There are so many steps are there. But if you follow the memoryless property of this exponential distribution, so this is nothing but m minus n here. So now it is a greater than. So either you can use as 180 to infinity. Lambda is this. Okay. But I always prefer to use the CDF. So you can write this in terms of the CDF 1 minus. This is nothing but f180. So what is the f of 180? How you find the f of 180 is 1 minus of 1 by 45 into 180. So you can see that. So once you substitute, you will get the same answer. Look at one more example is the life length of the electric followed again the exponential distribution given with parameter. So parameter is lambda, because in the exponential distribution the parameter, and you can see that this is again related to the time period. What is the probability that the components survive at least 10 months? At least 10 months, given that he already survived at least, so equality also more than 9 months. Okay, so what is that? This is there. Now again you can use this formula of the A condition B if you want, but if you can write is directly as x greater than 10 minus 9, that's a 1. Okay. So now you can write in the, you can use this either as a 1 to infinity of exponential distribution. You can substitute the value of here. Otherwise, you can write it as CDF form. Okay. So how you write 1 of f of is 1 minus e raised power lambda of x is here. So you will get the required answer as here. Okay, so there is no need to integrate the again and again, just use the CDF always. Look at one more example is there. The time required is again the exponential distribution with parameter half. So this is given to you. You have to find the probability that it repair exceeds the 2 hours. So first question is here. So look at that. So your task is this. You can use by using the PDF or by using the CDF. Okay. So I will move it one by one. So if you write in the CDF, you can write like this way. It's a greater than, you can write here. So it is f1 of minus f of 2. You can calculate this as here. On the other hand, if you calculate this by CDF, PDF, x greater than 2 means 2 to infinity. Lambda is nothing but my half and so on. So you will get the integration is here. Once you substitute e raised power in minus infinity, e raised power minus 1. So what is the e raised power minus infinity? 0. This is 1 by e. So you can see that the answer is remain the same. Now what is the second part is, what is the conditional probability that repair time at least 10 hours given that it exceeds the 9 hours. So that is the required task you have to find. So again you can use the memoryless property. This is 10 minus 9, 1. Now you can write it as x less than 1. But CDF you need the equality sign also. But what is the x? X is my continuous random variable. So there is no problem about this one, because probability at the single point is 0 for a continuous random variable. Continuous random variable. So you can write it as f of 1. So what is the f of 1 is 1 minus e raised power lambda times x. Okay, remember what is the CDF is here. Okay, x is this is my x. This is my lambda. So you can substitute here, you will get this answer. Or otherwise you can use also as a CDF. Once you will get this, so you can integrate this from 1 to infinity of this. So what is the integration of this? E raised power minus x by 2 of minus 1 by 2 to infinity. So half will be cancelled out, so it's minus 1, it's minus infinity and minus of 1. So you will get again the same answer. Look at one more example is there. The length of the person speak over phone satisfy exponential distribution with mean is 6. So this is the mean of the exponential distribution. So what is the mean of this? 1 by lambda. So it means the lambda is minus 1 by 6. What is the probability? So first part is more than 8 hours. You need to find this. Okay. So how you write this? You can write in terms of the CDF. Greater than means this is my f 1 by 8. So what is f of x? 1 minus e raised power lambda of x. So this is the required answer. If you want to find this second part between 4 and 8, so you can write it as f of 8 minus f of 4. Okay, so you can substitute the value of f of 8, this 1 by 6 of 8 minus 1 by 6 of 4. Okay, so after solving you will get this as the expression. This is nothing but my 4 by 3, this is nothing but my 2 by 3. So these all the expression are with the help of the CDF. You can also solve this question with the help of the PDF. So how you solve this with the help of the PDF is, you have to integrate from x greater than 8, this is the second method, a to infinity of this. So once you solve this, you will get e minus 4 by 3. You can see this is the same answer. On the other hand, if you find the second part between the 4 to 8, you can integrate from 4 to 8 and you will again get the same answer, e minus 2 by 3 minus of minus 4 by 3. So that's depending upon you whether you want to use the PDF or the CDF. But I always prefer to use the CDF because there is no need of the integration. Okay, so what is the meaning of this line? The daily consumption of the milk in excess of the 20,000 gallon is approximately exponential distribution with mean 3,000. Okay, so this is the 3,000 and it is given to be exponential distribution. So you can find the firstly value of the lambda. Now what is the meaning of that? The daily consumption is 20,000. The city has a daily stock of 35,000. So look at that. Since the city has a daily stock 35,000, daily consumption 20,000. So what is the probability that the stock is insufficient? So firstly, you have to think that when the stock will be insufficient. When the stock is insufficient. Firstly, you have to think about that. Look at that. The city has the daily stock of this. And the consumption is 20,000. So when it will be the insufficient? When someone wants milk is more than 35,000, because the city has a daily stock of this. If someone wants to greater than of the 35,000, then definitely be the insufficient. But the daily consumption of the milk is 20,000, so it means this is the condition. So if this happens, then this is the probability that a city is insufficient for a single day. Look at that. Okay. Now since it follows the exponential distribution, then you can follow the Memoryless property. This minus. Remember that you have to follow this property greater than n, which is nothing but m minus n, only if x follows exponential distribution, not for all the distribution. Okay. Now how you find this? You can find this with the help of the CDF or by the PDF. So if you want to find it with the help of the CDF, you can write this expression as 1 minus. So here. So this is the probability for the single day. But how many days you want to select? 2 days. Okay. So how you select that? So you have to find the probability of the 2 days. So your required probability is this. What is the axis? Number of the days on which stock is insufficient. Okay, so this is the discrete distribution because number of the days is always with the discrete. So what is the minimum number of the days and the maximum number of the days? Minimum is 0, minimum number of the day, and maximum number of the day are 2. So it means n is my 2. Probability of the insufficient is this. So look at that. What is that? N is my finite. If n is finite, so it means it follows the binomial distribution. So it means you have to find this as a binomial distribution. NCX probability P and Q is this. Okay. So this is the answer. Okay. Otherwise, you can also use the other method. So what is that? Since both the days are selected at random and they are independent, so what is the probability that it is insufficient for both the days? So it means probability of the one day for both. So both means intersection on the second day. And what is the probability of A intersection B if A and B are independent? Yes, this is nothing but probability of A multiply probability of B. So it means you have to find the probability of one day multiplied by second day. So this is the probability for a single day. So this is the required. So you can see both have the same answer. So this is the simple procedure you can follow for the exponential distribution. Remember always that you can follow the CDF rule. It will be beneficial, and always apply the memoryless property. If still there is any doubt, you can ask me. I love to solve your query. We will meet on the next lecture related to the normal distribution. You can browse this link if you missed any of the previous video related to the distribution function or the probability and statistics. Till then, happy learning. Best of luck.